Right, okay, this is 2013 June, and it's question 7, which is the linear programming question. It's quite a big question. It's got 16 marks. It may take a little while. Okay, but I'll try and be quick, and hopefully the idea is pause it now, do the question, then watch me do it. If you're stuck, or if you're completely stuck, just watch me do it, and hopefully that'll be okay for other questions. So you've got X gold, Y silver, Z bronze. First thing you've got to do with any linear program is read the question completely, start at the top, work your way through. If you can work out some of the inequalities or constraints as you work your way through, because it's asking you to set up the inequalities and constraints, then do. If not, if you think it's a table, then just wait. Make sure you use the right variables. In this case, it's X, Y, Z. So I'm going to start with my X, Y, Z and set up a table for this information. So X, Y, Z, and we know we're going to put in roses, carnations and dahlias. Each gold, which is X, has 6 of these, 6 of these, 6 of these. Next one, 4, 6, 4. Next one, 3, 4, 4. Now, this is the sneaky bit. Paul then decides he wants at least 420 roses, which means this could be greater than or equal to 420. He wants at least 480 carnations, so the minimum is 480, so he wants more than that in carnations, but he wants at most, he wants less than or equal to 720 on the dahlias or dahlias, whatever they are. So we got 6x plus 4y plus 3z is greater than or equal to 420. 6x plus 6y plus 4z. Sorry, that's my weird z's, meant to not do those. And 6x plus 4y plus 4z is less than or equal to 720. That's the first bit done. It doesn't want you to simplify. I'm not sure you can, so that's the end of that. Or you could by 2 or something, but so it leaves it at that. If you simplify, that's absolutely fine, but that or equivalent is fine. So the next part of the question says, on a particular day, Paul has the same number of silver as bronze. This is their way of getting rid of 3 constraints and having a 3D shape or a graph to trying to have a 2D graph, which obviously we can only do with linear programming. We don't go into 3D. So I'm going to adjust this now. So if y equals z, then obviously we could rewrite this and you would end up with 6x plus 4y plus 3y, because that y and z are the same. So I could say it's plus 7y is greater than or equal to 420, which, strangely enough, looks very similar to the one they've given us, which is my show that. Okay, so to do it as a proper show that, I would write 4y plus 3y leads to 420, and then 6x plus 6y plus 4y goes to 6x plus 10y is greater than or equal to 480. The answer they want is half that, so now I'm going to halve it as 3x plus 5y is greater than or equal to 240. That's my other one. And then 6x plus 4y plus 4y is less than or equal to 720. And that's not what they got. They've got half of that. But I'm going to write it as 8y first of all. And then I'm going to halve it. I can't halve it. How did you end up with that? Oh yeah, no, that should have been 6. Then 3x plus 4y is less than or equal to 360. Okay, so that's all that. So that's pretty good. So at the moment we've got our 3 marks for doing the constraint and we've proved our show that. So that's really good. Next bit says Paul makes a profit. Okay, so Paul does make a profit, bless him. And his profit is £4 on a gold, £2.50 on X and £2.50 on Y. Whoops. Okay, given X and Y is the same for this one, you're going to say the profit then, like the previous one, is 4x plus 2.5x and 2.5y and 2.5z would then be 2.5y plus 2.5y gives you 5y. So this is the profit that we're looking for on our objective line. Then it says we've got to draw it. So I'm just going to clear this off and we're going to look at drawing it. So our profit is 4x plus 5y. Okay, so if we're drawing these, we've got 6x plus 7y equals, we're going to draw 420. So we have our x and our y. When x is 0, y would equal 60. When y is 0, x equals 70. 3x plus 5y equals 240. When x is 0, y equals 48. Y is 0, x equals 80, doesn't it? 16, 24, yep. And 3x. So when x is 0, y is, falls into that, goes 90. Y is 0, it goes 120. Okay, so that should give you something to draw. Remember, you can multiply up any of these points, or no, you can't. Take that back. So that's that done. Then you have your profit margin. This is the bit we can multiply up. This is what we're looking for in this case. So remember, you've drawn all your lines, and we'll come back and look at those. When you do draw your line, what you've got to do is remember that you wanted greater than or equal to, greater than or equal to, and less than or equal to here. So if you've drawn your line, you imagine that x is 0, 0. So if x is 0, 0, is 0 less than or equal to 420? Greater than or equal to 4? No, it's not, so we don't want this side. So this line is 0. If we take this point again, greater than 240? No, it's not, so we don't want this side. In this case, is 0 less than 360? Yes, it is, so we don't want that side. Okay, so you get rid of the side you don't want. We'll put that together and I'll show you in a minute. Last thing, we create a number for our profit to help us get the gradient and get S. So we multiply the 4 and the 5 together, which gives us 20. Once we've got that number, then we can produce our x, y like we did before and give us a line. The line then helps us get the gradient, and we move the objective line up and down to maximise or minimise our objective. So when x is 0, y is 4. When y is 0, x is 5. Okay, let's have a look at what we've got. Oh, that's not a good start. Oh. No, that's the one we want. Right, so this is it. This then you would write in is your feasible region. Okay, feasible region, and the solutions will all be in the corners, A, B, C, D, or not the corners, the change of gradient of E. So looking at that, we ended up with our profit line being P equals 4x plus 5y. What you could do, if you didn't have to draw on the objective function, is to put in all these values, where this is the point 0, 60, this is the point 0, 90, this is the point 120, 0, and this is the point, what's that, 50, 60, 70, 80, 0. And this one you'd have to find. The only way you could find that absolutely is to hone in obviously on my graph, guesstimate on yours, or do simultaneous equations on these two lines, which they don't generally do with AQA, but they definitely do with Excel. Okay, so we wanted to do that, that's fine. Alternatively, remember we had 2 points, x was 5, where we had 20. When x was 0, y is 4. When y is 0, x was 5. So when x is 0, y is 4 and 5. That's what we're looking for. Multiply up, go for 40 and 50. Okay, this would be my objective line. If I think about moving that across, I've possibly got a solution at B, and I've possibly got a solution, a maximum solution at C, which is moving away from 0, 0, and the line, it's crossing the axis at a higher point as I move the line away from the origin. So I'm just going to test those 2 points. So I'm going to say my profit at 0, 10, so at B, I got 4 times 0 plus, 90 times 5, gives me a profit of 450. And at C, I've got a profit of 4 times 120 plus 0 times 5 which gives me 480. That's my maximum point, and that's at 120, 0. So the X is 120, so I'd have 120 gold and 0 silver. But what you must include at this point as well is that my X and the Y are the same value, so I'd also have 0 bronze. Okay, that you need to put in, otherwise you will miss the mark. And so if it is related to something well, it will be because it's a real problem you're solving, you have to then go back and think about the real problem you're solving. Right, back to the question at hand. Next part of the question then says, here, C. On another day, Paul makes the same number of silver and bronze. So we've got everything that we've had before, but the profit has changed. So the profit is going to be 2x and then 6 on each. So you're going to have 6y and 6z, which we know now it's going to be 2x plus 12y. Okay, if we're going to do it like that. So, because that would be 6y plus 6y, because that z turns into y because it's the same number, so you end up with 12y. Going back to our graph and getting rid of all the calculations. Okay, so we'll get rid of that. We're keeping the same graph. The only thing that's changing is our profit. So our objective line will obviously change. Right, so if that's the case, our new objective line was 2x plus 12y. Okay, again, I'm going to come up with the value, which is 2 times 12, to see if I can help me organise my gradient. If x is 0, y is 2. If y is 0, x is 12. To put in my line then, if you think about it, x is 0, y is 2. 2's on this side, then your 12 should be there. So I could do 20, wherever it is, to 120. Okay, thinking about that, so this is my objective line, thinking about that moving up, the maximum point has got to be B, basically, because it crosses at C already. It's not going to be A because you've got B further away as you move further away from the origin, so that is good. So, subbing in B, I'm going to have a profit is 2 times x, which is 0, plus 12 times 90. It already looks big. So 12 times 90, 10 times 90 is 900, 180. And that would be the profit for this one. So that's not the final answer because we want to know what you've got. We have got no gold. We have got 90 silver. But the actual profit thing was 6 silver and 6 gold, which is why you got 12 of it. So we were also going to have 90 bronze. Yeah, because they were the same number of each. So that is how you get it, because you get £6 profit on each in reality. And that's that one. So hopefully that's a whole paper. Oh.